We're Group 10, and here are some of the takeaways from our Distributed Systems project. Our project, the Dupe, is an auction-style bidding application where users can post items to be bid on. Users register to the bidding application and can place their personal items up for bid. Other users can join the bidding group for specific items to bid on these items. We also incorporated game elements to the bidding system that allow bidders to use certain tricks to gain an advantage. Our application consists of distributed user nodes that communicate with one another to conduct the bidding process. Items for sale are bound to a particular node, and all data concerning the item is stored in memory. This is to prevent any one node from being a single point of failure. In this way, the data management role belongs to the current seller of an item. If this seller node is lost, then the data associated with that node will be lost as well. However, the system will still be operational. Data is replicated in the system by having it sent to our central server, so the actions of posting items, removing items, adding users, and removing users can be recorded. Although data for each item is located in memory of the selling node, it also exists here in the central server. This information is also backed up to our backup server. As was just mentioned, our system contains a backup server. Using the primary backup model, failure of the primary server is tolerated through the connection to the backup. A bootstrap server facilitates connections between the nodes and the servers, allowing the nodes to connect to the primary server with the option to also connect to the backup. If a server goes down, it will recover the necessary data on restart from the other server. From a node perspective, failure is handled through heartbeat messages. Sellers communicate with buyers of a particular item through heartbeat messages, to which the buyers respond with an acknowledgement. If either party fails to receive the expected message, they take proper action. In the case of the seller, an unresponsive buyer is removed from the potential buyer list for that item. For the buyer, the specific item is removed from its list of potential bidding items. The seller also sends heartbeat messages to the server so that data associated with that seller can be removed if the server does not receive these messages. The main skills challenge for our group was to code the entire application in Python. Traditionally, Python was used as a scripting language, and as such, most of our group's familiarity with the language was in writing scripts. With this project, we were forced to use it as more of a traditional language and develop an entire program with it. Specific to this point, we had to learn and understand the networking principles and object-oriented functionality utilized in Python. Development also required our group to learn and use PyQt and PySide for the user interface, which we were previously unfamiliar with. Another new technology that we had to employ was Amazon Web Services. Specifically, its cloud hosting service EC2, which we use to launch our authentication, primary, and backup servers on virtual machine instances. From these new technologies, our group is better versed in the Python language and is more proficient at developing with different programming paradigms. From AWS, our group has gained the insight into managing cloud resources in terms of launching, securing, and monitoring these resources using the different services that AWS provides. Our first major challenge was work distribution. Because of the nature of our system, many of the components relied on communication with other components of the system, meaning that no one portion is isolated in terms of development. This meant that during development, integration was a difficult task for components developed by separate team members. A related challenge was the consistency of code. Because of several developers existing in the project, our group used Bitbucket to try to maintain a level of consistency between each developer's code base. Despite this tool, there were still instances of manual merging of code that needed to take place. Our final, most significant challenge was the full system test. Unit testing of smaller code blocks was simple to accomplish. However, when the full system was integrated, many bugs present in the code had to be discovered and fixed, which proved to be a lengthy process.